I have to make this quick because my phone doesn't have any storage left, and also I couldn't convince my family to do this with me. So for this special Teach Another Human Being, it won't be a human this time, it will be my favorite teddy bear. But I assure you, he's a great listener and is definitely going to grasp these math concepts after I explain them to him. So here's our word paper, and we're gonna get started. So Teddy, do you have any idea what an imaginary number is? He said no. So imaginary number is what happens when you try to square root a negative. You can't square root a negative, but you can sort of solve the problem. Not solve it, but you can get a complex, not a complex number, but a number without just saying you can't do the problem. And so what you do is that we have this problem right here. It's the square root of negative 49. So you know, since you're good at basic math, that you can square root 49, because 49 is 7 times 7. So if this was normal, the square root of 49 would be 7. But there's a negative there. So what does that mean? Well, a square root of a negative is going to give you I, because the negative is a negative 1, because there's nothing there. So you can assume that that's an invisible 1. And the square root of negative 1 is going to equal I. You start getting more complicated when you start raising I to a bunch of different powers, but eventually you can just divide those by 4. That's a little secret. And so Teddy, if you would kindly try to work out this problem, you would take 7, and then you would add I, and so it's just 7I. And that's the components to an imaginary number. That's where the I is, imaginary. You can add imaginary numbers to real numbers and make them complex numbers. Do you understand that? So now that you've got that concept down, here's a bit different of a topic, but still within the stuff we're going to be on for the test tomorrow. So this is a equation set equal to 0, 2w squared plus w minus 2 equals 0. You've seen stuff like that before. That's stuff that you would normally factor. Well, you don't have to factor, especially when it's not going to be like a perfect answer. You're not going to get good zeros, x equals, you know what I'm talking about? Like when you factored up something where you would end up having like x squared minus 7 equals plus 12. Something like that, where you'd end up having x minus 3, x minus 4 equaling x equals 3, x equals 4. So we're not going to get that. But what we can do is plug it into something called the quadratic equation. And the quadratic equation is kind of complicated looking, but it's really just when you plug in numbers. That's all you have to do with it. So Teddy, we're going to look at the quadratic equation, and I don't expect you know this, but I have it memorized because I learned it in my 8th grade algebra class. I learned it as the negative boy goes and adds and subtracts. I don't remember the rhyme for that one, but he does add and subtract here. And he doesn't want to be a square. That's a square root. And then the boy is a little bit of a square, so he gets squared. And then plus 4 chicks that are awesome, so that's A, and cool, which is C, all over 2 more cool chicks. 2 more awesome chicks, which is 2A. So it's a bit convoluted, but you eventually just memorize that's what it looks like. That's the quadratic formula. So now that we have that, we can take this equation and just plug in the values. And do you know what an A, B, and C value is? You do know that, I bet, because we covered it in chapters before, and I'm sure you were paying attention when I was doing my math homework, weren't you? He was. So if you plug this into this, and the B value, since it's just W, that's an invisible 1. So we have negative 1 plus or minus 1 squared, which is 1, plus 4, 2, which is the A value, and then negative 2, which is the C value, all over 2 times a, which is 2 again. And so, if you grab a calculator, fit in your little pause, and do 1 plus 4 times 2 times negative 2, it's going to give you 17, all to the square root, 16 to the square root, and then 17, because you have to do the plus 1. There you go. Yes. He corrected me. And so, and then obviously 10 times 2 is 4. 2 times 2 is 4. And so, you can't square root the 17, and there's not like there's a negative sign in there, so we can't apply what we just learned about imaginary numbers to it. It's just going to say negative. Square root of 17. But we can't just get rid of that minus 1 plus or minus. But we make that, and we're not going to put it in as plus or minus, we're going to put it in as 2 separate answers. So eventually we're going to get, if you turn it into 2 different solutions, you would have negative 1 plus square root of 17 over 4, and then negative 1 minus square root of 17 over 4. Does that make sense? And so your answers aren't going to always look like that. Like, sometimes it is going to give you a good answer where your x values are going to be it's like actual good numbers, but sometimes they're not going to be able to be simplified down and square rooted, so you're going to have bigger, more complicated looking things. But as long as you make sure to plug in things correctly, you're going to get the answer you're looking for. Understood that? You did. Thank you.